In the last video, we set up a bank with a customer array list. We added a method on bank to add new customers with validation to check if a given customer is already stored on our list. It's time to do some testing, so I'll go to the main method on the main class and create a new bank, then add a new customer. Bank equals new bank with the argument Chase. Bank.addNewCustomer with the name Jane A and amount of $500. Finally, print the bank object. Here I create a new instance of a bank, then add a new customer, Jane with an initial deposit of $500. Let's review the output. You can see that a new customer was added, and we also get the standard toString method text for a class. Let's update the bank class and generate a toString method. This time we get a better representation of what the bank class consists of. Our bank class doesn't expose its customers, meaning there's no getCustomersGetter method. The only way we want anyone to be able to add a transaction is through the bank, with a customer name. Time to add the addTransaction method to the bank class. The method is public and void with the two standard arguments, name and transaction amount. Customer equals getCustomer passing name. If customer is not equal to null, they exist, so call customer.transactions, chaining a call to add with the transaction amount. The addTransaction method allows transactions to happen through a bank instance, which first gets a matching customer, then the customer's transactions, adding the transaction to the list with the use of autoboxing. We need a way to see the customer's transactions, so I'm going to create the method print statement next. I'll make this one public as well. Looking at the addNewCustomer method, I made that one public as well, which is necessary so we can call it from main. Retrieve the customer if the customer is not found. Exit the method. The first thing we do in this method is to attempt to locate the customer record by customer name, calling the getCustomer method to do that. Remember that getCustomer is marked as private, so is not directly available outside of the class. If null is returned, meaning the customer was not found, then we simply return from this method, doing nothing. We could throw an exception, or return a null, or something else along those lines. I'm really just keeping it simple here, especially given the method is just printing a statement. If a customer is found, we want to print out the customer's name and the transactions in a well-formatted way. I'll add the code to do that now. First I'll print out 30 dashes, then the customer's name, and a heading. I'll use a for each loop for customer transactions, and use printf to print out transaction amount and whether it's a debit or credit. In this code, I first print a line to separate entries using the repeat method on string, which we've used before. Then I print the customer name. Note that I am using the accessor method on our customer record and not the name passed in on the method. That's because we want the name formatted in uppercase, which was part of the record creation. Next, I print out the transactions using a for each loop. And here is the unboxing part of the challenge. You can see I've set up a local loop variable typed as a primitive double. This means every entry in our array list gets unboxed, then assigned to this primitive variable. And then I print out a formatted statement using printf. Remember that specifiers have additional options, and we use one here for the transaction amount %10.2f. This prints a double value with a width of 10 and a precision of 2 decimals. Finally, I print out whether the transaction was a debit or credit in parentheses. I'm using a ternary operator to check if the amount is less than 0 to determine what will get printed. And that's it. I'll add a couple more transactions for Jane and print her statement out in the main method. A debit transaction for $10.25. Another debit for $75.01. Print them out. Time to run the program. We get the list of Jane A's transactions printed out, formatted, and specifying if the transaction was a credit or debit. Notice that it didn't matter what case I used in Jane A's name, it found her customer record in each of these instances. Okay, so that was the auto-boxing challenge, where we created a simple bank application that kept track of a list of customers, and each customer had a list of transactions. Finally, for good measure, let's test the code for a customer that has not been added. Bob S. Add a $100 credit transaction for Bob. and print it. What will get output? Let's check. You see that in both cases, Bob S isn't a customer of our bank and no transaction information was printed. And even though we created a customer instance for Bob S, we can't really add him to our bank. The only way to add a customer to our bank is using the only constructor we have, which takes a name and an initial amount. Okay, let's add him that way, with an initial deposit of $25, and I'll change the case. Bank.add new customer passing Bob S and 25. And running with this code now, we get a statement for Bob S. I hope you had fun with that and can start to see why array lists with wrappers make your job easier in a lot of ways, rather than attempting to manipulate everything as a primitive array. In the next video, we're going to look at another special type in Java called the enum. See you in the next video.